Vraag 2. The displacement of a particle is given by S is equal to 3t plus 5. We need to determine the displacement of the particle at certain time signatures. We can substitute the time into the equation for the displacement and find the displacement. At 1 second, it's 8 meters, and at 4 seconds, 17 meters. We are asked to write down an expression for the velocity of the particle. The velocity is equal to the first derivative of the displacement, and if we calculate this first derivative, we find an answer of 3 meters per second. In question C, they ask us to determine the velocity of the particle at 1 second and at 4 seconds. However, there is no variable into which we can substitute the time, and that means that the velocity at 1 second and the velocity at 4 seconds are both equal to 3 meters per second. Therefore, we can say that the particle is traveling at a constant velocity. Now we are asked to write down an expression for the acceleration of the particle. The acceleration is equal to the derivative of the velocity or the second derivative of the displacement. If we find the second derivative, we will see that it is equal to 0 meters per second squared. If we have to find the acceleration at t1 or at t4, it will in both instances be 0 meters per second squared because the particle is traveling at a constant velocity. Question 3. The displacement in meters of a particle is given by S is equal to t squared minus 6t plus 9. We are asked to determine the displacement at 0 seconds, at 3 seconds, and at 6 seconds. This is a displacement formula, and we will substitute the time into the equation and find that the displacement at 0 seconds is 9 meters, at 3 seconds the displacement is 0 meters, and at 6 seconds the displacement is 9 meters again. This will allow us to describe the displacement of the particle. At 0, it's 9 meters, it drops down to 0 and bounces back up to 9 meters again at 6 seconds. Determine the velocity of the particle at 1, 3, and 5 seconds. Velocity is equal to the derivative of the displacement. If we find the derivative, we will see that it is equal to 2t minus 6. And if we substitute the given times into the derivative, we will see that at 1 second, the velocity is minus 4 meters per second. At 3 seconds, the velocity is equal to 0 meters per second. And at 5 seconds, the velocity is equal to 4 meters per second. Write down an expression for the acceleration of the particle. The acceleration of the particle is equal to the derivative of the velocity, or at the same time equal to the second derivative of the displacement of the particle. When we find the second derivative, we will see that it is equal to 2 meters per second squared, and that means that the particle has a constant acceleration of 2 meters per second squared.